screen is coming in fine. Yep.
Is that better?
Yep.
Awesome. Great. So, hi everyone, and today I'm going to talk about how we use CRDTs in a mobile mesh network. And so the gist is that we use CRDTs at our company called Ditto to sync data over a mesh network using local area network technologies, peer-to-peer Wi-Fi, and Bluetooth Low Energy. A little bit about me. I'm Max. I'm the co-founder of Ditto. And I've always loved to build collaborative edge applications that sync in real time. And edge might be IoT, mobile, or web apps. And I absolutely hate loading spinners, which caught me into the whole space of local first. And a little fun fact about me is I traveled so far 800,000 miles around the world, enough to go around 32 times. And I'm almost always using all of those miles to show off CRDTs used in business applications with local first principles to our customers. So a quick disclaimer, we're not going to go into CRDTs in depth. I think there's been plenty of talks that have talked about what a CRDT is. Rather, we're just really going to discuss how CRDTs enable us to build collaborative apps using a mobile mesh network and why a mobile mesh network is important in the market today. So in this talk, you should consider CRDTs as a building block of a very large and much more complex system. As you'll see, CRDTs is necessary but insufficient to create a peer-to-peer product. It doesn't hurt to get through some of the merits of CRDTs. If you've ever followed the space, you know that CRDTs are a cornerstone of being able to do local first. Now, there are other types of data structures, but they stand for conflict-free replicated data types, and they help you build collaborative apps that have eventual consistency. So apps that use CRDTs can remain available and operational even during network failures or partitions. So since each replica or app can be updated independently, usually the system will continue to function accepts writes locally. Once any of these devices stop making writes and they all have connectivity with each other and they replicate, they will all deterministically resolve to the same answer. The most important feature of CRDTs and why we use them at Ditto is that they require no central coordination. And I'll talk about that in a little bit. So today, this is how we build collaborative apps. Even apps that don't use CRDTs, you have to be able to share data by a hub and spoke model. So a mobile device that you're using, like for example on Google Docs or Notes, and you want to sync with another device that has to go all the way up to the cloud and back again. Even things like iMessage or WhatsApp, which might not really use CRDTs, they all have this sort of architecture. But in order for them to collaborate, you really need to make sure that they have excellent internet and system health for data to move around. But the real world does not work like this. If you've studied distributed systems, you know the entire space is dedicated towards mitigating the possibilities of system or network faults. So especially when you add mobile and web apps to the mix, the system can be incredibly brittle due to things like cloud outages, backend system outages, app crashes, latency, and more. So the system doesn't work really well. And in a lot of places where we see local first, we see a lot of them are really focused on desktop or native applications to give it that real good collaboration feel. We see a lot of this. But a whole set of industries actually really need local first more than anyone. This type of like cloud dependent collaboration architecture isn't acceptable for a whole host of these types of apps, like deskless workers whose phones are their office or their tablets are their office, and they're moving around in places like hospitals, airlines, factories, or point of sale systems in your restaurants or retail situations, but also a large industry for robotics. Most of these apps really just need to talk to each other. And so it does look a little bit absurd if you go into some industries like aviation, for example, and those devices are right next to each other, but they can't talk to each other. They have to talk, like for example, a lot of airlines actually build applications where they sync data all the way through a satellite connection to AWS and then go back to another device just a couple of feet away. So we just decided that there were mission critical applications that could use the local first paradigm. And when we say mission critical, it means that the business depends on that function. Meaning, if you can't get data to move here and there, you're not getting your food, or the nurse can't pull up allergy records for a specific patient, or a robot isn't able to function inside of a factory. So we can't solve every single issue, but at Ditto, we asked if it's possible to solve most of these issues. So my co-founder and I, when we first started the company, we took a look at all of the devices that we had, like most popularly, obviously, a mobile device, because for frontline workers or deskless workers, that's what they have. And they have 5G and LTE chips and a Wi-Fi chip that also has the ability to talk peer-to-peer, as well as a Bluetooth chip that we all kind of know and love. Local First is really focused a lot on being able to talk when you have internet connectivity, so storage is really important. You see a lot of people putting an emphasis on embedded databases to be able to do optimistic writes and conflict resolution at the database level. But the beauty of some of these Wi-Fi and Bluetooth chips is they actually now have the ability to talk to each other directly. They could actually talk to each other directly, just like you've been able to use AirDrop while you go for a hike and send a beautiful photo to your friend. So that's how we started Ditto. It's a software developer kit. It's completely cross-platform. You put it inside of your application and use some CRUD APIs, and they will talk peer-to-peer with each other. In addition, because they're mobile, we also have the superpower of being able to talk even to devices that are not directly connected to you. And here's where that local first paradigm really comes into play. So even when apps are completely far away from each other, so say like two people are syncing really close to each other, and they go really far into opposite corners of, say, something like a warehouse, they're really far from each other, they can still edit and show data. And that's where that local first paradigm comes in. And when they come back to each other, those devices are able to sync back data all together as well. So all of those deltas and CRDT changes are able to talk to each other. Ditto is not just a CRDT-based database. It is both a CRDT-based database and a mesh network. It really takes the two of those two things to come together to create a product that we've been quite successful at deploying in a whole host of different industries so far. At its core, you have this database, and on that mesh network side, we've created something that we've called the Ditto Rainbow Connection. And the Ditto Rainbow Connection is what actually transports all of those CRDT deltas or changes from one side to another, and is the underlying network transport protocol that helps shuffle a lot of the data that moves around. And so when we look at Ditto at a high level, we have two types of peers. It's a peer-to-peer database with a mesh network. And that means that we have small peers, which we call for the mobile and IoT and embedded space. Those are the ones that are able to talk to each other in the factories, in the warehouses, in the airlines, or the restaurants. And the big peer is a system that we have typically in the cloud, but can also be in the edge, and they can sync with each other. So you have this amazing architecture that is very, very different from this architecture. It means that we can actually be able to talk to each other between devices, multi-hop through devices, go all the way up from one device to another through the cloud, and then make it up to a device that's even disconnected. And our Ditto Rainbow connection is something quite special to us. So devices can talk to each other. These two databases can talk to each other over something that we've taken a long time to perfect. And they can talk to each other over Bluetooth Low Energy, over the local area network, over peer-to-peer Wi-Fi, USB, or even through the big peer. So there's so many different ways for devices to talk to each other that's quite special. And that means that if you're connected with each other over one protocol, we'll prefer that one protocol if it's stronger over another. So it can constantly bounce back and forth. And we're really proud to say that even though devices could be connected directly through each other to another device, you can actually have the first hop be Bluetooth Low Energy, the second hop be local area network, and the third hop be whatever you'd like. So the resiliency is quite nice. In the very beginning, if you turn on a whole bunch of Ditto devices, they first discover each other and they start creating a mesh network graph. And that is what enables devices to say, hey, I'm connected to you, you're connected to another person, and we can actually make these multi-hop links between each other. In the event that, say, one device does leave, maybe they clock out for work or something like that, we can actually reheal that link. And now a lot of this stuff doesn't have to do with CRDTs, but they're absolutely essential for being able to transport CRDT deltas and changes between each other. It is a database. So one of the things that we love about Ditto is that database APIs are really friendly for a lot of people to build. Like they're just CRUD operations that we know and love. And you can insert and you can use a SQL-like syntax, which we call DQL, DQL in Ditto. You can insert, update, remove, and do anything that you kind of expect from something like SQLite. But the most important thing is that to sync data between each of the peers, you have to use a subscription system. So you register a subscription such as this. So you select star from cars where color is yellow, for example. And that is what actually gets synced around. This is how everything works right now. So let's say we have two peers. I'm showing you a small peer and a big peer, and there's a whole bunch of documents, like say 7 billion documents. Now that's why this query-based sync is really important for us. The device on the left is going to ask for all yellow cars. Well, it doesn't have a lot of space because it's a small peer. What ends up happening is it interrogates the other side and then gets over those small, those yellow car documents all the way onto the left. Now they're in sync. You don't have to sync anything that you don't want. That's the beauty of the query-based synchronization system. There is no full synchronization that happens in Ditto. Unless you absolutely want it, you declaratively specify that out. It's quite efficient in being able to understand, even if they disconnect or reconnect, if there have been any changes. So let's say they disconnect and reconnect. If both sides don't make any changes, what ends up happening is there's no data sent. So it's super, super efficient, even for very latent scenarios. So quite good at that. And at the end of the day, we can also take a look at some of the property-based synchronization technologies that we have in Ditto. For example, let's take a look at one specific row item inside a Ditto database. So we're not taking a look at all of the documents, but let's say we make a couple of changes on the left side. So for example, this car document, we're going to change mileage and year. We use a delta-based state CRDT system. And when those two changes are made on each side, we actually zip on over just the deltas, making sure we preserve all of the bandwidth that we have between each of the devices. And now they're completely in sync. And I'm sure everyone's going to ask, what happens if we make concurrent changes? So concurrent changes in Ditto are going to be when two devices make concurrent changes on the same property. This was a very big learning lesson for us at Ditto. We found out that almost all of our customers can only understand time. I know this sounds a little bit disappointing that you don't have a very robust conflict resolution system, but it turns out that this is the thing that almost all of our customers really understand. So what we do is we use a hybrid logical clock. There's a paper on this. I'll be able to share with you on all of it. But we are able to put a timestamp. We found out that our customers are totally happy on losing a conflict as long as they understand that someone did something after them. Because when some data flips back and forth because of network partitions, we've noticed that customers have always been able to understand, oh, some person did something after I did. Let me go talk to that person. So in this example, it starts off as a chord at t=0, and then later the one peer sets it to RAV4, and the peer on the bottom sets it to Camry, and suddenly both sides will end up saying Camry because Camry is the latest one. So we always do last write wins. Now we have other CRDT types that we have, for example, counters, replicated global arrays, add wins maps, and we have more coming down the line, but it seems like almost 99% of our customers actually prefer just last write wins because they don't mind the conflicts. They just mind the conflicts. They just want the conflicts to be in order of like a whiteboard. So if I wrote something on a whiteboard and someone erases something after when I leave, my brain immediately thinks someone wrote something after I did. So in debugging with customers, we had the ability to understand their preferences, and it came back always down to time. Another thing that's not so much of a CRDT, but people ask us is how do we sync files? And this is one of our favorite systems for syncing binary data. So let's say peer 1 is next to peer 2, and peer 2 syncs 33% of a very large 100 megabyte PDF. Peer 2 leaves because their boss called them off to the left. And what ends up happening is if there's another peer around, say peer 3, that has the same document in the same state, what ends up is peer 1 will continue from the 33% and sync the rest of it from peer 3. And I believe I have a couple minutes left, but one of the things I definitely want to be able to share with you all is how do we make secure connections between each other. In the very beginning, when you create a Ditto instance, and I don't show this because this is a very large product, you create a peer key, very similar to how you create a new key ready for consumption if you have a new MacBook and you want to sign up for GitHub. You can put some arbitrary data in JSON format to our identity service, like a username, secret info. It's an arbitrary JSON file. Once the identity service takes that, we send it over to an authentication webhook that you understand, and you can figure out how to challenge that data. And you can put whatever permissions of which documents this one peer can or cannot write. So very similar to GitHub, right? So when you log in, you understand which repos that you have readability, writability, pull request ability, commenting ability, and that's what's embedded in this flow, as well as your identity. It comes back to the identity service and we sign some information. And that's how devices can understand I'm Max and this is Sally, and we create a TLS 1.3 connection using all of this information. That means that even though devices could be connected, like for example, this device could say this is Max, I also understand this one's Sally because we understand the same identity service. So yep, that's pretty much it. And I want to thank you all for seeing how we use CRDTs in a very, very large product. You can understand that CRDTs are a core component of Ditto, but it's a combination of the replication system, the mesh network capabilities, as well as all of these systems coming together into making a nice, beautiful API for you to use. So I would love for all of you, if you're interested in building a local first, but also a mesh network powered CRDT application, whatever that may be, to go to ditto.live and sign up for a free account and then start hacking away. We have SDKs in Rust, JavaScript, Kotlin, Flutter, and more coming out. React Native and others. So we'd love to get your feedback. Some of these SDKs are more have been used for a long time, and then some of the SDKs like React Native and Flutter are in early open beta. We'd love all your feedback because we want to make sure that we constantly make these SDKs better and better. Thank you.
That was an awesome talk, Max. Especially the partial download and then like completing it on another peer. I'm really curious how you managed to pull that off. If you don't
Thank you
mind,
so much.
I'd like to take over the share. Do you guys have like a concept of like IPFS, like CIDs, content addressed kind of like partials of a giant blob?
We kind of do have something similar to that for the data type called attachments. It's not exactly a CRDT because we don't know what parts of a PDF you've changed. It doesn't have that metadata. Yeah, we just have like a checksum.
Good stuff. Get ready for a lot of questions at the end. Next up, we have Raz. I'm really excited to have him. If you haven't seen him, he's been part of the community and he's been active. He's been a great help to me. And also, the user owned web is a concept that is near and dear to my heart. So I'm looking forward to what Raz has in store for us with Basic DB.
Hello, can everyone hear me?
Yep, coming in great.
Okay, cool. I'll just share my screen. Hey everyone, my name is Raz. Nice to meet you all. So I've been working on this project for quite some time, and I just want to share it with you all. It's pretty early, but I would love to get everyone's feedback and thoughts on it. So let me just share my screen. Okay, can everyone see?
Yep, coming in great.
Wait 1 second. I think I'm sharing my app. Let me try again. Yes. Perfect. Okay. Are we good?
Yes, coming in great.
Okay. Cool. So yeah, hey everyone. I'll just go ahead and start. So I guess I don't need to tell anyone how local first is awesome. We know local first is awesome. But one thing which was actually emphasized a lot at the local first conf in Berlin, if anyone was there, is that like local first does not equal local only. And there's a couple of reasons for that, right? Like local only apps mean that like your data can be lost if you lose your device. That actually happened to me like a couple days ago because my phone decided to like reset on its own for some reason, and I just lost like a bunch of data because it wasn't backed up. You also want like collaboration, and so and also like if users want to like publish content online, you need like internet connection. So basically, what we need is like in addition to local first, you also want something that has backups, is collaborative, but is also private. Um, and so there are a couple of solutions that people end up doing. You could build a peer-to-peer network, like using Ditto. And so if you use Ditto, it's not as complicated anymore. I mean, it's complicated unless you use Ditto. But peer-to-peer stuff is still, if you have never done it before, it's still a lot of work to do. You can build your own sync servers, which once again is a lot of work. Now you have to maintain a database, which kind of defeats the purpose of local first. Um, or you can let your users upload their own data to like iCloud. So I know iCloud has APIs for this. And this is a pretty good solution for a lot of apps. I think one of the apps that was at the local first conf, I forget what it was called, but they use this service and it's been really beneficial for them. And the benefit for this is now you don't have to pay for your own database because your users just upload their data to iCloud or to Google Drive and it syncs and it's fine. The problem is that it's very limited. There's not very like you can only use it for backups, but you can't really use it for anything else, right? So like you can't do real time stuff. Um, it's just good for that one particular thing. Um, so the idea that's been going around is that what if we gave everyone their own private database in the cloud, right? So like this would be a proper database, but it lived in the cloud, so all your devices could connect to that database. Um, Databases for everyone, and so that's kind of what I've been building. It's called Basic, and it's a federated database network for user-owned data. Um, and what that means is essentially every user gets their own data store, and the apps, like if you have like a local first apps, instead of backing up that data to a database that the company owns, or even like a Google Drive or an iCloud where you might not be confident in the privacy of that, you basically sync your data to a server that you own, that you fully control, that's encrypted with your own keys. So it kind of gives you all the benefits of local first, but also gives you all the power of the cloud. So now you can build a lot more kinds of applications with this sort of architecture. Um, yeah, and so essentially what Basic becomes is kind of like a full stack database for local first apps. So if you use Firebase or Supabase, it's similar to that, right? Where I want to give everything you need to build an application. So like you need auth and user management. You need to build indexes, or even like real-time libraries for React or REST APIs. Um, but all of that centered around like a local first thing. So we can just dig into what that actually looks like. So this is the developer portal. So if you want to create a project, we just create a project, and then you get a database endpoint and API keys. So the first thing you would do is you set up your schema, your database schema, and then what you can do is you get APIs that you can use, like REST APIs, as well as like a React library as well, which I'm still working on. Um, but yeah, so the REST APIs you can use to read, write data and stuff. And the other thing that I'm working on is I'll show you guys is basically the React library. What that'll do is that'll basically make your app local first whenever you use it. So instead of storing like whenever you store data, it would store first to like if you're on the browser, it would store to IndexedDB and then it would sync to the user's cloud. And you can also view all the users that you have for that application. And what this looks like from the user perspective is like this. So basically, every user gets like their personal data cloud, and you can log in and you can see every app that you've connected to. And then this is where you can control like permissions for that data, or like if you want to disconnect from an application and still have access to your data, you can do all that from this dashboard. So for example, here's an example of like a local first, very simple like notes app right? You can just like write some new notes. And the login, like the flow here is the user would log in with basic, and we redirect them. Actually, this might be broken. Let me try again. Okay, sorry, I think the login flow is broken. But they would log in, and then it would redirect to this page where they can give it access, and then it would just basically give them access to their data. Yeah, so that's mostly it. That's sort of the general idea. If you want to try it out or have any questions, I can take any questions and stuff. But yeah, that's mostly it. I'll stop my screen share and then I'll just answer any questions.
Yeah, we're planning on doing questions at the end, but just a
Okay.
quick one would be like the identity component. Are you also using key pairs? What's the story there?
Yeah, so that's like key pairs. Like you can log in with like a Google provider, like whatever provider you want, or you can log in with like a crypto wallet. Then you can use those key pairs. So yeah,
Interesting.
it's kind of like a decentralized identity where like you can bring your own identity if you want to.
Yeah. Nick Graff had a wonderful talk in Berlin for the folks that weren't at the local first conference a month ago, actually. Wow, time's flying.
Yeah.
We're gonna have him on in September, and it'll be wonderful to see what the unifying theories are around there. Uh, all right. Next up, we will. Let me just pull up the talk slides. Sorry about that. Short and sweet, Rishi. All right. So our next speaker, if you've seen him around, he's one of the earliest members of the local first community. Is Andre. It's great to have you here, and he will be telling us about Mainframe, and I love that name. Me and him have talked a lot about like personal data warehousing. Like I said, Raz and Andre are people that are really aligned to what I think the future should look like. And over to you.
Yeah, awesome. Thanks for the intro. I'm gonna quickly share my screen over here. Okay.
Coming in great.
Perfect. Thanks everyone. Thank you for being here. And I'll just get straight to a quick demo, and then I'll get on with the talk. So for those who don't know, Toggle Track is not a service that I control, but is a service that I use to track the time that I spend on tasks. And this on the left is showing my small screen with my MacBook. And as I create a task over there, it updates the devices on the right, which I wrote the software for both of them. And then I can interact with the devices to react back on the third-party API service. And so now to explain what's going on here, I'll take a few steps back. First, hello, my name is Andre, and I'm building Mainframe. Mainframe is an open source tool to help developers sync their users' data from other apps. I write code, I make YouTube videos, subscribe, and I was previously at Microsoft in Valtown. And why local first? Well, as a developer, there's a lot of benefits. I get to interact with less layers. I don't have to worry about database, APIs, fetching, SDKs, caching, and none of that. A lot of local first provides some features for free. And so collaboration, data versioning, offline support, multi-device, free in quotes because it's not, you still have to do some work, but it's still a lot easier than implementing all of them separately from scratch. And it lets me build higher quality apps for less effort. But I not only build apps, I also use software. I also use a lot of software. And as a user, Local First provides me with a lot of benefits as well. For one, my apps are faster. There's no need for spinners. It works on multiple devices. It works offline, and it lets me collaborate with others. And also, it provides me with data ownership. And for today, I'd like to go a little bit deeper on the data ownership part. For the first four, you understand like what's the dream there? It's like, well, it's understand like the speed of light. All my devices work. It works offline, and I can collaborate. But with data ownership, I think that it unlocks an extra set of things that we can achieve. And so I'll start by showing a video by Andrew Lewis.
Okay, so this is the basic screen. What we have at the top is a query, an active query. Then we have the results being displayed on the timeline, and we have an idea of results over time on the left. So what we're seeing now is a query for everything I've done on GitHub. And you can see like it's a range of information, like it's a ticket I created. Or what I can do now is add another verb, so verb like. So this is everything on GitHub that I've liked. So this is the repositories I've liked. Just to give an idea of the graph structure that I'm using for my system, we can turn on this visualizer here. So everything.
And so with this project, Andrew is pulling in his data from a lot of places in order to be able to query everything and interact with it. Similar project by Linus Lee is Monocle, where he built a personal search engine for blogs, tweets, journals, notes, contacts, and he can query everything at once. And so this is one of the scenarios that data ownership brings, is that you can now access your data and gather more information from different services that usually would be very hard to get. Another interesting thing that data ownership provides is potential, right? It's interoperability. And DXOS has been doing a great job kind of showcasing what can be done when you have two different apps being interoperating. And if you have interoperability, it opens up the doors for more home-cooked software. I borrow these examples from Maggie Appleton's talk, which you should totally check out the slides, and the videos will come soon. But people building finance apps, glucose monitoring apps, and sales apps, all of and these apps specifically required them to have access to the data that was already present in other software. And I myself build a lot of these personal apps. I track my time with Toggle, so I build like charts for me to know if I'm on track on things. I have a workout tracker gadget on the device to the left on my desk. I've tracked my gaming time on Switch, and I have this task display on top of my Stream Deck that I showed in the demo earlier. And you should subscribe to my YouTube channel, by the way. And so this home code software, again, borrowing from Maggie, can open the door for all these out-of-scope user problems and user needs to be solved by the user themselves because they own their data. And another example from actually Raz that just presented is, especially when you add AI into the mix. In this demo, he showed AI generating apps with basic DB with persistent state. Yes, I think this is the YouTube channel. Yes, correct. I think all links lead the same place. And so in this way, if you have if you have data ownership, and you can use AI to generate all these apps to fulfill all these like edge case needs that I'm like, it's an annoyance. I want them solved, but I don't have time to solve it, or like I can't improve on it. But AI might let us get there. And so this was kind of like to paint a picture of like the dream, not only of local first, but like also what if we get the data ownership right for users in the space. But that dream, the question is, how do we get to that dream? And I'm not just talking about like how do we build new apps with local first, but as I mentioned, I use a lot of software. I have notes apps, calendars, coding apps, music, workout, and I use apps on my computer and on my phone. And so for a developer, in order to rewrite these apps, it will take some time, right? And so if we need to replace an existing app, sure, we can like get inspired by the existing designs, but apps have a lot of features and hidden complexities. You're competing on the technical and the business side with them. It's a big commitment for the users to migrate from the old app into a new app. And one quote by Alexander Omenauer in his latest essay is that he had simple ideas for how email could be better, but in order to introduce even small changes to the email client, he first had to build one from scratch. And so what I'm trying to say here is that as much as I want all my apps to be replaced with local first so I can get all these benefits, like, can we bring some of these benefits closer in without having to wait for all these apps to compete on the business side and compete for trust and all that. And this is one example of an app that I built. As I mentioned at the beginning, I use Toggle Track to track my time, and I wanted like a UI on top at the time that I built the first version of this app to tell me like how far away was I with my freelance hours. Was like by the end of the week, like did I work enough? I was working 20 hours a week at the time, so it was like, did I reach that time already? Am I like too far behind, or am I too far ahead that I can like work on something else today? And I didn't find a way to like, hey, I want to create a widget that I can always see. I want to like have a quick link to see. And so what I did, I took the matter into my own hands. I learned their API, struggled through their authentication, and then built my own small UI on top of the data that they provide, which was a version of this about 6 or 7 years ago at this point. And so the type of apps that I'm looking into is how can we build on top of existing apps? By doing that, instead of trying to fully replace an app, you can, well, first, a lot of apps already have some kind of API, whether it's official or not. You can tackle problems for the long tail of users. So like if someone wants a specific chart for their YouTube channel, a specific chart for their tasks, instead of like, hey, let me rebuild a time tracking software and then build this chart, is like, how about I just build this one feature? And that means you can start with a smaller scope. There are some challenges with it though. Of course, the platform risk. If you look at what happened to Twitter API and the Reddit API, just killed so many business in the process. And the interoperability between creating a local first app, between a local first app and a non-local first app is not something trivial. If you think about it, we're building CRDTs exactly to build a conflict-free replicated data type, but then at the point that you introduce a node in your graph that doesn't use CRDTs, now you lose part of that benefit. A few of the challenges that I faced when I was trying to build a small prototype is that if the API doesn't have webhooks, you're going to have to rely on polling. So forget all the live updating between two places. You will need the translation layer if you're using CRDTs or OTs into like a snapshot-based API. Whether it's as the events are coming, you group them and coalesce them into like something. But this and the opposite way as well. If you're like, hey, this new event, this time entry was updated, but if they don't tell you what was updated, then you need to like do some kind of diff. You need to know what was the last version that they knew about. And so that involves a lot of work. How to detect and handle conflicts is another thing, right? If you're offline and you make changes on your local first app, and then someone else goes and makes a change in the cloud, how are you going to account to detect and handle conflicts in that case? And of course, you don't control their server or their interface. So if there's a problem, you won't. It's not up to you to fix it. You can send messages and all that, but it's not guaranteed that you're going to get your solution. And this set of problems and this dream of data interoperability is what is one of the motivations that drove me to build Mainframe. And as I mentioned, it's an open source tool, helps you build apps that sync with other apps. And today, the way it works, if you want to build an app for yourself, you can just go in here, choose which connectors you want to use. You can see the data for each of these connectors. So in this case, I'm seeing my GitHub repos, and I can use the Mainframe API to send requests, and then it will proxy through Mainframe. And then we also created a playground in the app to be able to quickly test the data. So in this case, it's a React component showing my Spotify top tracks. And I used AI to what if I could generate a UI on top of my Spotify top songs? And in this case, it did great. Of course, it's AI, so it works sometimes and doesn't work some other times. But then once you generate the component, I created a dashboard for you to be able to save those components as well. As I mentioned today, it's working if you want to build for yourself, and we're now building the next phase, which is helping, if you're building an app for others, help your users connect to your app and handle that authentication and API proxying, so that you can focus on the business of your app and build apps that kind of drive towards this dream, this vision of more data ownership, of faster apps and collaboration and multi-device. It's a long journey ahead to bring every software into local first. And even though we don't have to begin rewriting, screen by screen of every software, we can start by building these utilities around it that use local first, but that work with the existing data, so that it make the transition between the cloud apps for users, right? Make the transition for users between cloud apps and local first apps to be a bit smoother. But it's a lot of work, and so I think we should start right now to rewrite it in local first. Thank you very much.
Awesome talk.
Awesome.
Also, love that you added the AI, sprinkle some AI on it, and then after seeing Damon's talk for React Native, I don't know, for React and React Native, he built dynamic cards by asking GPT to write the React code. Just
Yeah.
the potential for really creating dynamic apps is through the roof.
Yeah. A quick preview. We might actually spin that off into a separate product, because people are getting confused. Giving feedback on the AI and the dashboard instead. If anyone has a different opinion, please let me know. There are a couple questions in the chat.
Yeah,
from Mainframe.
we'll hit those. I just want to flag something, but one of your slides had a tweet from Raz. I don't even know if you made the connection, the video. It's a wonderful tweet. Raz, do you have the video around? I would love for you to kind of show the dynamically generated AI. Once we have the mainframe or the user-owned database or perpetual sync and peer-to-peer, the limit.
Yeah, I thought I mentioned during my talk that hey, by the way, this is Raz that just talked.
Maybe.
But maybe I skipped through some words. Sorry.
It's more likely that I'm DJing the recording and everything. All right, Raz, pull it up for us. Also,
Yeah, no, I appreciate the shout out. I think you definitely mentioned it, so I appreciate that.
Nice.
And then me and Andre have talked. We talked a lot about this. I think we spent an hour last time just giving each other feedback over this. Because the idea of user generated dashboards over your own data is really cool. Yeah, I can share. I can just share the screen real quick. One sec. Here you go. And I'll send a link. This is This is a demo. Can you guys see?
Yeah, maybe full screen it.
Okay. There we go. Yeah, so you just type in what you want. It generates the UI for you, and then all this data is persistent and it's local. So it'll just stay on your device. We got a sandwich. And then you can update the app too. So if you want to add a feature, you can say like whatever, and it'll update the UI and it'll update like the data, like database structure as well. So like this is using basic under the hood. Yeah, so it'll basically update the app.
Nice stuff.
And you can make like anything with it. Yeah.
Yeah,
I'll send a link in the chat if you guys want to.
And then Andre, if you have a link as well, just drop that in. This is that time of the meetup where we end the recording and the broadcast and just kind of hang out with each other. We don't really have a